Greetings, Saintsmen. This is instruction for Algebra 1, lesson 2.6, which is solving absolute value inequalities. Jump right into this lesson, and the directions effectively are just going to be the same each time. They're going to be to solve and graph these problems. It's going to look like this. We're going to have an absolute value of x plus 3 is going to be less than or equal to 2. And how do we get after them? Well, first of all, let's review. If we have less than or less than or equal to, this is typically going to be called a conjunction. Versus when we have greater than or equal to, this is what is going to be a disjunction. Conjunctions are usually and problems, right? And disjunctions are the or problems. So on the and problems, we shade in between. On the or problems, we shade the outside. So again, we're going to do a split here because this is a conjunction. First thing we're going to rewrite is the problem x plus 3 is less than or equal to 2. Now, when we do these problems, we need to remember that, again, we're going to have x plus 3, right? Same absolute value. But remember what happens in an absolute value. We have to account for the positive and the negative outcome, right? So on the right side, it's going to be what's going to also have an outcome that's going to be negative 2. But when we do that, right, we're going to flip our sign, right? Because recall a couple lessons ago, when we divided by a negative, we also flipped our sign. It's logically what we're going to use to complete these problems. So here we go. We're going to do a minus 3, both sides. That's going to cancel out. X is going to be less than or equal to negative 1. That one's done. Minus 3. And x is going to be greater than or equal to negative 5, all right? So then we're going to merge these guys together. We have the x, and of course the smaller of the two values is going to be the negative 5. Of course, we're going to flip which side it's on, right? So look at this guy on the right. The inequality still opens up to the x. That looks good. And again, we're just going to effectively recopy this guy right over here, which is going to be less than or equal to negative 1. So there we go. It works out as we predicted it would. It's a conjunction, okay? Of course, my requirements, I need to know where everything is in relation to 0. Well, there's negative 1. There's also a negative 5, okay? These are both closed points because they're equal to, it says, not just less than. And as a conjunction, we're going to shade in between these two values. So on the line in between. And we're done. There's our graph. Let's do another. We're going to solve and graph. The directions are rather straightforward, but the work itself might not be. So the absolute value of 3c minus 5 is going to be less than negative 2. Now, gentlemen, before you jump into this to solve, I want you to look at this. By default, right, this is going to have no solution. Okay? Why? Well, think about this. What's the result of your absolute value? It can't be negative, okay? So it doesn't really make sense for us, okay? We're not going to have a negative there, so we're going to go ahead and just, so when we see that if we have the result, when it's a less than, and we have a negative over here, we're going to shut it down and write down that there's no solution. So let's do another. Solve and graph. Straightforward directions, okay? Absolute value of x plus 1 greater than or equal to positive 3. Step 1, let's do our split. This here, what we're anticipating is that this will be an or a disjunction problem where we're going to have to shade the outsides, okay? So here we go. X plus 1 greater than or equal to 3. So we copy just as is. But here we go. We're going to go x plus 1, and we're going to flip our sign, and we'll flip our sign. You'll hear me say that over and over again in the process of these problems. Flip the sign and flip the sign, okay? Let's go ahead and do our inverse operations, right? 3 minus 1 is going to be 2, so minus 1. X less than or equal to negative 4, okay? So this is our or. We're done. Now watch this. The x wound up on the left side each time, which is very nice for us. We need to show where these are in relation to 0, right? We have our negative 4. -4, getting ahead of myself. The 2, which is going to be closer to 0. 2 is on the right of 0, negative is going to be on the left. These are both going to be closed points, right? And with that variable on the left side, it's nice because then we can actually just use the direction that the inequality points into, right? So for greater than 2, points to the right of 2, and here's how we show greater than, right? Including the arrow. And then for less than -4, it's going to be to the left. Again, that inequality points to the left with the variable on the left. So we're all set. There you go. There's our graph. All right. So what happens when we have these disjunctions? We're going to solve and graph. Where we have the absolute value of 12 plus w greater than or equal to -5. Well, gentlemen, we can deal with this negative. If we have the event that we have it with a greater than, what this winds up being is this is going to be all real numbers. So when we had it when it was less than, right, going back, the negative, it was no solution. The default here, when it's greater than, it's going to be all reals. Okay. Next, let's do another solve and graph. Three times the absolute value of 2t minus 3 minus 5 greater than 16. All right, let's see what our outcome is. Well, before we can make a determination about if this is going to be a conjunction or disjunction, we need to have that absolute value on the left all by itself, okay? So I like to complete these problems with the absolute value on the left side before I even do my split, okay? So here we go. Imagine this, sidebar. Imagine if I had 3 times x minus 5 greater than 16. What would be my process, right? Well, I would do my inverse operation of plus 5 first, and then after that, I would divide by 3, okay? So the same thing is going to apply here. I'm first going to add 5 to both sides, okay? So I'm going to have 3 times the absolute value of 2t minus 3, still greater than, and then 16 plus 5 is going to be 21. Next, I'm going to divide by 3 on both sides. So 3 is going to factor out, and now I have the absolute value of 2t minus 3. That's going to be greater than 7. Okay, well, now we can do our split. Now we still anticipate between conjunction and disjunction. We're anticipating disjunction that we're going to shade on the outside. Let's see if that actually happens. So 2t minus 3 greater than 7. And we have a 2t minus 3, and we're going to flip our sign, and we're going to flip our sign, less than -7. All right, let's solve. So we're going to add, I'm going to do that in blue. Add 3 to both sides. Have a 2t greater than 10. Now I'm going to divide by 2. Now I haven't divided by a negative, so I can keep my sign. So t is going to be, oh, that's not very good at greater than sign. 2t. T is going to be greater than 5. Continuing on, plus 3, cancels out, right? So I have a 2t less than, a -7 plus 3 is a -4. I'm going to divide by 2, divide by 2. Okay, and I'm going to have a t less than -2. And this is my disjunction. Now watch, let's go ahead and graph this guy. Watch what happens. So I'm going to put my 0 in relation to my, right? In relation to 0, -2 is going to be on the left, positive 5 is going to be on the right. I'm going to put this -2 a little bit closer because it's going to be closer to 0, okay? Both of these are going to be open dots. And again, because my variable's on the left, I can actually use the direction. Now it is shaded to the outside because it's an or a disjunction, but also because greater than 5, right? It's going to be the right of 5, Or with the inequality pointing to the right, we can shade to the right. Same thing with the variable on the left, inequality pointing to the left, meaning we can shade to the left. That's how we would do less than -2 anyway, and there is our graph. All right, last problem we're going to work on today. We're going to have a -3 times the absolute value of 2 minus 4u plus 5 less than -13. Now, gentlemen, we can't make any sort of assessment like with the less than right there until we actually have this absolute value by itself, okay? So remember, we need to get rid of the other stuff. So let's go ahead and do our inverse operation. So of course, we're going to subtract 5 first from both sides. So we have -3 times the absolute value of 2 minus 4u. And we are less than, right? Because the 5 minus 5 cancels out. -13 minus 5 is -18. Next step, we're going to divide both sides by -3. Watch what happens here, though. We divided by a negative, so we have now 2 minus 4u by itself, absolute value of 2 minus 4u by itself. But we must flip our sign because we divided by a negative. Now we have a greater than 6. Now we're anticipating this is an OR problem or a disjunction, okay? Watch what happens. Let's do our split. 2 minus 4u greater than 6. 2 minus 4u, flip the sign, and flip the sign, less than -6. Let's solve these problems separately, right? -2 minus 2, -4u is going to be greater than 4. Okay. Divide by -4, divide by -4, and guess what happens? Again, we have to flip our sign. U is going to be less than -1. Same deal on the right problem, right? Subtract 2. So now I have -4u less than -8. Divide by -4. Hey, look what happened again. U, got to flip my sign. It's going to be greater than 2. This is a disjunction, very definition of it, right? Because take a look. Let's graph it. In relation to 0, I have my -1 on the left, I have my +2 on the right, -1 closer to 0. These are open dots, right? And because I have my variable already on the left, I can actually just follow the direction that the inequality points into. -1 has a little points to the left. 2 has the point to the right, include the arrow, and there's our graph. It actually had a couple things switching there, so there's quite a bit going on in that problem, right? We're going to have to make sure that we flip our signs when appropriate, especially when dividing by or even multiplying by a negative. Your homework assignment is posted on Canvas. Go ahead and begin. Good luck.